Good morning. Today I'm going to talk about the gold foil experiment and a scientist named Ernest Rutherford. Now, this was back around 1900, and scientists were still trying to figure out the structure of the atom. They were putting together evidence, but they hadn't got all the pieces yet. So if you remember the last time they thought about this plum pudding model, which was the atom was this big ball that was mainly positively charged, and it had some negative charges kind of embedded throughout. Well, this is not the correct model, but this is what they thought at the time. So Rutherford devised an experiment to test this model. And what he's got is a source of alpha particles, which are 2 protons and 2 neutrons. This means that's positively charged. And he shoots this beam of alpha particles at a thin sheet of gold foil. So what was he trying to do? Why did he do this? Well, he was trying to understand, again, the structure of the atom and test the current model, the plum pudding model. What he expected to happen was when he shot these alpha particles at the gold foil, if it was like the plum pudding model, there would only be a few of these alpha particles that got deflected. Most would just pass right through. Only some that would be slightly deflected off to the right or to the left. And that would be it. That would be all that he would see. Now, that's not what ended up happening. What he found after he ran this test a number of times, so shooting all these particles through, passing through the gold foil and seeing where they deflect, most did go straight through or get slightly deflected, but some, and a significant amount, would get deflected almost back towards the source of the alpha particles. So it's almost like they were like shot this way and then bounced almost directly backwards. So this was very unexpected when he made these observations. But this told him something new about the atom. All right, let's take a look at this page, and it's still showing the gold foil experiment, but it's showing what actually happened. Now, most of the alpha particles, like I said, just passed straight through, or they had a slight deflection. But why did some get significantly deflected? Now that happens when an alpha particle hits the nucleus directly or head on. So it's going right towards the nucleus, it hits it like dead on, and it bounces almost back towards its origin. But the question is why, when the alpha particle hit the nucleus, why did it bounce back so significantly? And the reason is, remember that the alpha particles have a positive charge to them, right? And what we understand now is that the nucleus also has a positive charge to it. And just like two magnets, when you have two positive or two like charges, they repel each other. And that's what was happening with the alpha particles. That's why they were deflected so significantly in these couple of instances, was because the positive alpha particles hit the positive nucleus and they bounced backwards. So this told Rutherford that the plum pudding model was incorrect. It told him that most of the atom was empty space. So there was this huge amount or huge portion of the atom that was just empty. To give you an idea of our current understanding of an atom, imagine a football stadium, okay? So this is a whole atom. This is the size, the volume of the whole atom, this football stadium. The nucleus of this atom would be about the size of a blueberry. very small nucleus in a very large volume. So that's why most of these just pass right through. The alpha particles, they just pass right through because they're going through all this empty space. But it also told them something else besides just the fact that it was a very large empty volume. It also told them that the nucleus had a positive charge. And this is a big difference from what they understood at the time, back in 1900, with the plum pudding model. So, hope this helps. Thank you.